Okay, I'm live. Hello, everyone. As you can see by this text block here, I got some work done at school. I'm sorry I haven't fucking done any work on this for like the past 3 days. I've done it off stream a little bit, but I mostly just played Minecraft on stream. That was pretty sucky of me. I'm sorry. But I'm gonna lock in today. My main goal is to get my car to drift. Um, so let me show you that real quick. So I'm gonna show you my code here. So I have some notes I took, a lot of notes actually. Um, Basically did some math. Um, that means also I replaced a bunch of the bad code I had from before. Um, it's just the way it was before, except it doesn't turn when you let go of the rotation key, because I thought that was stupid. It just stops rotating and keeps going in the same direction. And then I have it sort of carry over, sort of rotating depending on how long you've been holding down the rotation key, variables for it and stuff. And then I'm gonna use a vector 3 for the movement instead of a transform dot. Yeah, I'm gonna use a transform dot a transform dot position to move the car. Basically what that means is instead, because transform dot position means that it goes solely off of the car's given rotation in a given instance, which is not what I want, because I want it to drift, which means that if it's drifting, it can be rotating and moving in a direction that it's not pointing at. So instead, I'm going to be using a vector 3 as a completely separate thing, and then I'm going to be using math to determine which direction it goes in. So essentially, I've already figured out how to apply it. I've already figured out how to convert degrees into the vector 3 for movement, because basically vector 3 is like a Cartesian coordinate, and then it's 0, 0 is where it is, and then you plot a point, and the direction it is going is the direction it'll go, and then the length is the speed, I'm pretty sure. So if I use the unit circle, because I was learning like some pre-calculus stuff, if I use the unit circle, that's a circle with a radius of 1. You can take the formula cosine squared plus sine squared equals 1. That means that as long as I have the cosine of, and because it's cosine and sine, it automatically assumes the unit of degrees. So I can just use like degrees as my unit, and then I plug that into the cosine formula, plug that in the sine formula. So I have cosine of degrees for my x, sine of degrees for my y, and then 0 for my z because it's 2D. I'm using vector 3. You can use vector 2 if you want. But I am preferring to use vector 3 here. I don't know why. Maybe it's because you can also change the layering of it in that way, because Unity is fundamentally a 3D engine. Anyway, so because I'm using cosine of degrees and then sine of that same degrees, it's cosine of the degrees squared, sine of the degrees squared, and then if you add them together, you get 1, which means that the length of that line will always be the same. So the speed of it won't change depending on the direction. It'll always remain constant. So that's basically what I'm doing here. But I also have to figure out how because when I have the degrees of the way it is, I have to account for the direction the car is currently facing, I believe, and also the direction it was already moving before. Because you have to factor in the player's input as well as previous factors in order to sort of mush them together into the formula that determines the degrees that the car is actually supposed to move when accounting for drift and whatnot. So that's basically what I'm going to be doing today. Sorry if that was a bit of a mouthful, or earful. Also, I'm not able to stream on Kick today because the platform's down, I think. Or, I don't know, it's really slow for some reason. But yeah, let's get started. I should open the code actually, because I'm gonna be doing a lot of actual like C# instead of actual like Unity stuff. This is mostly gonna be programming. Yep. Okay, let's see here. So I have to put together how this was working. So the whole applying it thing I've got down so far, but I still have to figure out how to mush together the two numbers. And one of the numbers I don't even know how to determine yet. So, because you factor in the transform rotation of the car, so that's one of them. It's already there for you. But I have to figure out how to determine this other variable I made up called car init rotation or car inert rot vector. Wait, it's not even car inert rot vector anymore. I changed the name, right? Yeah, it's just called car inert rotation. It's not a vector anymore. Because it's just return. It's only doing one way of rotation, so I only need one float. I don't need a vector 3. I'm just reading my notes I have here. Okay. Okay. I'm just gonna move this down a bunch because I don't want to look at it. This makes sure the speed rot reset carries over when you switch keys without fully letting go. I think I know how to do it. Because when you press, here's the thing. For either accelerating or braking or rotating, in both instances, for one singular update of it, for one singular update of it, it's by a constant number multiplied by this other thing that I don't care about, multiplied by time.delta time. So it's basically a constant multiplied by time dot delta time. So that's basically the given force for that update. So I think that if I want to do it a certain way, I just compare the ratio of this constant times time dot delta time to, or rather, not the ratio of it's on one side, it's the constant times time dot delta time, and then on the other side, it's the the sort of speed that the speed and direction it's already going in. So that means that I'm gonna have to learn how. That means that I'm gonna have to learn how to calculate magnitudes. Okay. Because they're two different forces acting against each other. Okay, that makes a lot more sense. But also that means I'm gonna have to learn a type of math that I learned earlier in pre-calculus, but I didn't really learn it because I wasn't paying attention in that class. So now I'm gonna have to relearn that calculus. Okay, yeah, sure. Yes, okay. So what is it like? Damn, I hope people actually watch my stream because. Okay, so how to calculate two forces pulling an object. I might oh right, I gotta show window capture 3. Whoopsies. I'll keep it the same size. I'm trying to figure out how to calculate the resultant force, or whatever. When an object is subject to several forces, the resultant force is a force that alone produces the same acceleration as all those forces. For example, if four forces act on a block and cause it to accelerate 1 meter per second squared, resultant force. Reason why the resultant force. The thing about several forces, though they were a single force, it means that to determine the effect that several forces have on an object, we only need to determine the effect that a single force has. To how to find the resultant force. If we know the mass m of an object and the acceleration a produced by the forces that act on it, we can find the resultant force using Newton's second law. Indeed, according to Newton's second law, the force F that alone produces the acceleration a on an object of mass m is F equals ma. This force F is our resultant force, so we can write resultant force equals ma. Now the resultant force R, the direction is a, and its magnitude equal to the product ma. Oh, resultant force equals magnitude. Oh, wait, no. Resultant force equals magnitude in the direction of A. Okay. For example, if a box of 1.5 kilograms is subject to 5 forces, make it accelerate 2.0 milliseconds square northwest, and the resultant force. Subject to 5 forces. So I'm going to show that when an object is subject to several forces, F1, F2, the resultant force R is the vector sum of those forces. R F1 plus F2 plus F. This is not a mere sum of the magnitudes of forces, but the sum of the forces taken as vectors. Yeah. To explain this clearly, we will now go through all the cases that can happen, from simple ones in which all the forces are parallel, to more complex ones in which the forces are not parallel, and shall find the resultant force in each of them with the help of examples. Okay, two forces acting in the same direction. So that's 7 newtons, right? Yeah. Yay, two forces acting in opposite directions, you subtract them. Two forces equal in the so of course, because they cancel each other. Two forces not equal in latitude, then you subtract. More than two forces, you add these together on each side, and then you subtract them from each other. 7, 11, subtract 4. Yeah. Subtract the smaller from the larger, of course. Now we've got this. Okay, two forces that are not parallel. What's live stream saying? Oh, no viewers yet. Oh, I wish all my viewers would come back. I wish my viewers would come back. Two forces that are not parallel. In the previous cases, we have forces that are parallel to one another. It's time to consider the case in which an object is subject to two forces that are not parallel. For example, let's assume that we have a block of two forces, F1 and F2. F1 has magnitude 50 newtons and is applied 5 degree angle. F2 magnitude 60 newtons is applied horizontally, shown in the free body diagram below. Okay. F1, 50. F2, 60. Remember that, Cody. Okay. How do we find the resultant force R in this case? The first step is to draw coordinate axes on our free body diagram. Since one of the two forces is horizontal, for convenience, we choose the x-axis horizontal and the y-axis vertical. Place the origin at the center of the block. Okay, 45, 0. Okay. Next step is to determine the x and y components of all the forces that act on the block. Oh. Do you use f1 of x is equal to f1 cosine 45 degrees. F1 of y is equal to f1 sine 45 degrees. Okay, so we can identify whether it uses cosine or sine for these, because sine is the y-axis and cosine is the x-axis, just by how it works. So, and then f2. So x equals f2, because we don't need to determine that yet. And f2 sub y equals 0. Right, because this one's the sine, and then this one's the cosine. So cosine would be 90, which is 1. Well, cosine would be cosine of 90, which is 1. And then sine would be sine of 90, which is 0. Okay, if we sum all the x components, we will get the x component of the resultant force. If we sum all the x components, we will get the x component of the resultant force. I mean, I could just make a formula for this. This is easy. Let's make a formula, plug it all in, and then it's easy. In theory, of course. In practice, I don't know. I don't know, man. I don't know. Here, you know what? I'm just gonna pull this up so it's easier for all to see. I'm just gonna do this. And then I'm gonna move this behind these two. Actually, I'll just shrink this one down. And then I'm gonna drag it in front. Or I'm gonna... Oh, I did the wrong thing. Whoops, I'm silly. I gotta drag the Visual Studio 1 down, and then the Window Capture 3 up higher. Okay. And then we'll just shrink this one. Okay, I was looking at this. This is what I'm looking at, alright? F1Y, F1X, blah blah blah. Using cosine and sine. We can plug this stuff in. Okay. If we sum all the x components, we get the x component of the resultant force. So F1 of x, F2 of x, no, F sub 1 sub x, F sub 2 sub x. So the x component of this, and the x component of this. Equals R sub x. Right, so this is just showing us what happened up here, okay. And then R sub x equals, so it's expanding it here. R sub x equals F sub 1 cosine 45 degrees plus F sub 2. And it shows us the thingy, because F sub 2 is 50, right? Is F sub 2 50 here? No, F sub 2 is 60. Alright, because this is F sub 1 cosine 45, and then F sub 1. Oh, is it multiplied? Let's use a calculator to verify. Make sure this is multiplication, because you never know. 50 times. Okay, so cosine 45 times 50. Wait, what? F1 of F sub 1 sub x plus F1 cosine 45, right? 50 cosine 45. 50 cosine 45. Am I going crazy? That doesn't equal 95 newtons. That's 86.2 something newtons, not 95. Cosine 45 degrees. It's that number. Cosine 45 degrees. I don't know what you're talking about, buddy. Did you do... Is it cosine 30 degrees, maybe? Maybe you did your math wrong? Cosine 90. Wait. Sine 90. Something's terribly wrong with this calculator. Cosine 90. Sine 90. Okay, it was set to rad instead of deg. I think that might be it. So if I do cosine 45 times 50. Wait. 50 cos 45 plus 60. Roughly 90, or roughly 95. I don't know why they rounded it without saying anything. That's not very fair, buddy. Shouldn't be rounding it like that. What about cosine 30? No, cosine 90. Cosine 45. Cosine 20. Cosine 90. Cosine 80. Cosine 70. Cosine 60. Oh, cosine 60 is 0.5. That's silly. Okay. But this isn't 60, it's 45. So this is roughly 95. It's not an equals, it's roughly 95. If we sum all the y components, we'll get the y component of the resultant force. Okay, same concept. So use those to find that. Really? It's just a Pythagorean theorem? Really? You really just use the square root of them squared added together? Really? That's it? You just use a Pythagorean theorem? Oh, I mean, I guess they are. Yeah, I guess that makes sense. The angle theta that r makes with r sub x can be calculated using trigonometry. Okay. This is sad. I have 0 viewers. Okay. Whatever. I'm still gonna stream for the rest of the night, because I gotta make it up to myself. The angle theta that r makes with r sub x can be calculated using trigonometry. Oh, r makes, like, from r sub x. Right, because you could also take the other theta value here, but you're taking this one specifically. So, theta equals inverse function tangent in parentheses r sub y over r sub x. Theta equals inverse tangent r sub y. Oh, it's just those two. Right, because you got these two. Equals 20 degrees. Thus the resultant force R has magnitude 100 newtons and directional angle of 20 degrees. Wow. I mean, I only have 2 right now, but I guess I can read up a little more. Well, let's examine the case. I think you just do the same thing to all of them, right? Yeah, you just do the same thing to all of them. And then you sum them all based off of x and y. And then you use Pythagorean theorem. Because you only have one x and one y. And then, if you wanted to do it along the z-axis, you just do this process twice, and then take these two and do the same thing again. Yeah, for the z, if you want to do it along the z-axis, you just do it with one of these and another one, and then you have 2 diagonals, and then you take the thing of those diagonals, and then you win. Or, actually, I don't know if that's, I don't think it's that simple, actually. That's a problem for another time, though. Okay, I think I get how to do this now. We're gonna have to make a new function, though. So we're gonna have to scroll down to methods and functions, update gas, update rotation. Now we're gonna make another variable called, I'm just gonna say void. Calculate This is the resultant magnitude. Or, wait, what is it called? It's like resultant. Just gotta make sure I'm right about this. R is a resultant force. Calculate resultant force. Well, calculate resultant force and set. And it's set final. Or we'll just say calculate resultant force and set variables. Alright, now we have a function for it. We can shorten this a bit. Calc result force and set variables. Okay, so now I need some variables for the resultant force. Oh my gosh, okay. This is fine. I'm fine. I'm a good person. It's nice. Let's just scroll down to the bottom. We have force 1 and force 2. I'd just like to clarify that this code is very experimental. In theory, it makes sense, but in practice, I don't know, man. I don't know. Okay. Calculate result force and set variables. Cool. So the variable we're trying to set. Well, I guess we could set multiple, but you. This song's kind of a banger, honestly. What is this song? Reality by Unison. Let's like it. Kind of a banger, I'm not gonna lie. How's chat doing? Oh, zero concurrence, really, dude? Does it think I'm spamming or something? Like, what's going on? Yeah, I'm just not being entertaining enough. I've been streaming for like 34 minutes, though. Usually people join. Okay, come on. I might have to update the speed. I didn't factor in the magnitude of this thing for speed. Ah, physics is so fucking complicated. I swear, if it's to the point where I have to like make a list of the different magnitudes and their directions, I'm like gonna actually rage quit. Like, is that actually what I have to do? Do I have to make a list of like do I have to create a new list object and then put in the different fucking like car speed magnitudes at a given point in time? Oh no, and then there's gotta be what? And when do they expire? No, I don't think that's how it works. No, because yeah, there's only one past direction and rotation. If you put it in outer space, whatever rotation and direction it's going in, it's going to continue doing that because of the laws of physics. So you only really need one previous rotation thing, movement rotation thingamajig, because that's just how it works. So I don't know. I guess I'll just. So then.
In the sky, gazing far into the night. I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through.
I gotta change the speed then. There's gotta be multiple speed variables. Not only do we need car inert rotation, but we need another public float, or not necessarily public, but we'll call this car inert gas speed equals 0. Public float, car final gas speed. Oh, okay.
Eyes in the sky, gazing far into the night. I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light shine through. If you believe it's true, baby, won't you let the light shine through for you?
Apologies, I will set this one to a large one because. You know what? Actually, I'm just gonna do it this way. Here's what we're gonna do. I'm gonna rename this small L. Wait, what? Wait, Visual Studio. No, that's gonna be small r then. Let's rename this. I'm just gonna rearrange my OBS real quick. Yes. Let's just lock that real quick. Expand this. And then this one. It's all right. It's gonna go right here. I don't know why it doesn't snap properly. Actually, let's do it like this. That's better. And then snap it. Doesn't snap. Okay. Cool. Fine. So Uni Project, small r, Visual Studio. Wait, Uni Project, small, Visual Studio, small. Let's duplicate this. I'll copy paste it. No, it went like all the way at the top, right? Yeah. Sorry, I'm just rearranging OBS real quick. Ugh. Cannot real quick, this might take a little time. I'm gonna rename this small L. And then we're gonna have window capture 3. We'll rename. Or no, let's copy paste this. Oh my gosh. Rename. Chrome. Small r. That's a good setup, right? And then we're gonna hide this. Hide the large Visual Studio one. I got the Chrome. Maybe it's like hiding. Hello? Is it hiding? We'll hide Visual Studio, Uni Project. Oh. Okay, here we go. Now we're gonna take this and just shrink it down. Like so, drag it over. Oh, whoops, wrong one. I'm so silly. Yo, where'd this one even go? Oh, wait. Chrome. Now we wanna take this. Slide it down. Okay. Bro, I'm going crazy. Like, what the fudge? What the fudge, huh? This one's supposed to be on the left. That's the right one. As in not the right one. Why is... Okay, I thought that one was locked, but I was just selecting one. So, alright. Okay. Now we got small versions of all of them. Now we just need large versions of all of them. Large Uni, large Visual Studio, No, no capture 3, okay. This should work properly now, but we're gonna rename this to Chrome Large. Alright, now I can properly show all of them. So I'm gonna show Chrome, and then the small visual. Sorry about that. Oh my gosh, okay. So I have to make a resultant force calculator. Oh, I know, sorry. Alright, so I've kind of figured out how to calculate resultant force, I guess. So now I gotta switch over to the code part and actually apply this. So we're gonna do that, and then... Oops, that one's locked for some reason. Okay. I want large Visual Studio, if I become small. Okay. Oh my gosh. Okay. Resultant force calculation. Using resultant force calculation. So slash this stores the inertia gas speed of the car's previous resultant force. This one's gonna store the inertia of the car in degrees. Of the car's previous resultant force. So the final words, the rotation of the car's gasping vector for the new resultant force. And then this one will say, this stores the final gas speed of the car's gas move. Oh right, this shouldn't say vector. It should say. Oh wait, I guess it is a vector. Of the car's gas move vector for the new force. So using resultant force calculation, I can plug that into the vector 3 of the. Okay, fine. Yes, this is fine. I learned about this. I learned about this in my pre-calculus class. And I never paid attention, so I had to relearn it. But everything's better now. Yay, everything's better now. Oh, I'm gonna engage with the chat. What's up, chat? How are you all doing? And do some crazy emoji. Like, what's the most crazy emoji I can do here? Let's do the laughing emoji, the gross emoji, the ooh emoji, the screaming emoji, the nails emoji, the crying emoji, the heart emoji, the poop emoji. There we go. That should help. Alrighty. Resultant force calculation, why? Brother. Oh my gosh! Okay. Resultant force calculation. Resultant force calculation. We need these 4 variables. Car inert rotation, car inert gas speed, car final rotation, car final gas speed. So let's just take those and just plop them in there, huh? Car inert gas speed equals 0. Car inert rotation equals 0. Car final gas speed equals 0. Car final rotation equals 0. I think we're just gonna comment these out for now, because we're trying to figure out how on earth this works. Because the reason why I didn't want to just do one singular speed variable is because if you really think about it, there are 2 different speeds acting against each other. Like, if you have something like this, where you have a speed going this way and a speed going this way, this one isn't going to just apply to, like, the new direction. Even if they're, like, making a new direction, it's not just going to just apply to it 100%. There's some amount lost from the, like, pulling. So the magnitude has to change because of that. It can't just be the same as the one speed variable, which means I need to account for both speed variables in the resultant force calculation. Like, ugh. Hello, Woolly Silver. What's up? What are you working on? Looks confusing. It's a Unity game. It's not for the Pirate Software Game Jam, but it's so I can learn enough so I can participate in the Pirate Software Game Jam. Yeah, so I'm learning that right now. Yep, just doing that. I mean, like what? Like, I guess I could advertise in the Pirate Software game. Chat, advertising chat. I don't really want to do that though. Fine, I'll do it. Let's just look up Discord. Discord. Alright, Discord. It's time for you to meet your maker. Yes, plot twist, I am the creator of Discord. Yo, why am I getting... Oh no, I never left Discord open. Oh, crap. Oh, they were on last night. What? Okay, he's calling. He's calling. I'm gonna turn the. Yo, Jax.
Yo, Cody, what's up? Wait, so you're coding a car that can drift?
Hold on, I gotta answer this person's question. Woolly Silver. What's the main problem you're solving for the Unity project right now? Well, it works kind of fine, but it doesn't have drifting yet, so I'm trying to add that. This project is separate from the actual game that I'm gonna be making during the game jam because they have to announce the theme still. But
Wait, what's
yeah,
the
I'm just
game
trying to get my
jam?
huh?
What's the game jam? What's that?
It's the PirateSoftware Game Jam. It happens on the 17th, I believe, which is in roughly 2 days, 1.5, 1.5 days. And basically the idea is you have 2 weeks to create a game along with a document that explains it. It's just a prototype. You don't have to make a finished product. And then you submit it, and then the judges review it, and there's like a top 10, there's prizes and stuff.
Oh, that's awesome.
But you can't start on it until they announce the theme because your game has to be based off the theme.
And they announced the theme, right? It's like cars or something.
Yeah.
So give me the rundown. What's your game about?
My current game, which is not for the game jam, is called Pixel Car Drift Race.
Uh-huh.
By the way, you're live, Jax. Just letting you know.
I know.
Okay, just gotta be sure. Um, so basically, the idea is you control like this car. It's W and S to go forward and backward, and then A and D to rotate. And there's like and stuff. And basically, the idea is there's these different enemies that sort of wander around or try to attack you. Um, and basically you have a certain amount of health and each enemy has like a certain number that represents how fast you should be going when you collide with it in order to kill it and get points. So
Oh, so you have to up your speed or lower your speed type of deal.
yeah. And then like the closer you are to the number, the more points you get and the more. Okay.
That's cool. Hold on, Cody. Give me a sec. Yeah, Auntie. Yeah.
Ooh, 245 subs. Let's go. I don't know who subbed. I'm pretty sure it was Woolly Silver. No, although I could be wrong. Hello. I'll tell Jax that you said what's up because he can't see this stream right now. Although I guess he just doesn't have it open. He could see if he was on stream. Da, 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 da. I love resultant force calculations. Resultant force calculations are my jam. My game jam. I love resultant force calculations. Resultant force calculations are the best. Just kidding. They suck. All right. Car inert gas speed, car inert rotation, car final gas speed, car final rotation.
Ninikara, ninikara,
Jax, Jax,
ninikara.
Woolly Silver said, "What's up, Jax?" Exclamation.
What's up, Wooly? I just call you Wooly.
Yeah,
How's it going?
I'll relay whatever dialogue they say. All right, I actually gotta like figure out how to do this because I read a thing that told me how to do resultant force calculation. Pretty neat. Uh, except the only problem is I have to apply it. I know how it works, but I have to now apply it.
Wow.
Um, probably gonna be Jackson. Probably gonna be doing a lot of programming. I might hop on
Go for it.
Minecraft at the end of the night though, but I can still stay on the call.
Okay,
Also, if
yeah,
Ian
perfect.
joins, we can do like a three-way call.
Yeah, I
You
love
wanna ask him if
threesomes.
he's? I can ask him if he's. Well,
Yeah, I'd be down for a threesome.
and Jacks are in call if you wanna join
Join the threesome.
phantoms. Um,
Let's get him in here.
I'm not be coding until um like 8 or 9, depending on how far I get. Then I'll switch to MC. Jack's join Phantoms.
Okay, for sure.
Or
Joining on
actually
it.
join Tirehead server.
Tirehead server?
Yes.
Is that in the same one?
Uh, just the Tirehead server. It's the pink,
I don't have
the pink. It says it has Tirehead on it.
I don't have Tirehead server.
What do you mean? Did you delete it or something?
I never had Tirehead server.
Oh, you're not on. Wow. Okay. Wow. I'm
Yeah.
still. I did invite you, but it's old.
Wow. You guys have a server
Okay.
without me, huh?
Okay.
That's
There
like
it
having a
is.
group chat without me. You basically just told me you want me to
I
treat
sent
myself.
the invite is in a
No,
I
no, no,
literally
no,
sent
no.
it
We
on
got beef now
January 8th,
for real.
2025. All right.
Me and Cody got beef. Hey, Wooly, would you like to know exactly where I'd like to know exactly where Cody lives?
Please